All right, let's go ahead and get started with Mole Podcast number 6. Today I'm going to talk to you a little bit about molar volume and density. Density is the amount of matter in a given volume. I'm sure you've learned that before. You've learned that probably in middle school. For example, down here you can see the cube on the left is less dense than the cube on the right. So that's fairly intuitive. Our units for there are going to be mass divided by volume, grams typically divided by volume in liters. However, you know how to convert between all of those factors anyways, so we're going to get some practice in this video doing that. Density is neat because it's a way to relate the mass to the volume without any reference to the mole. On the other hand, molar volume is the space that is occupied by a mole of the substance's particles. And in previous lessons, you've learned that a mole of any gas at STP will occupy 22.4 liters. You've also learned about molar mass. Just as molar mass was grams per mole, molar volume is liters per mole. So we're going to work through a few quick examples in this podcast. The first one here, you're being told the density of methanol at 20 degrees Celsius is 0.813 grams per milliliter. And then you're asked, what is the mass of half a liter of this alcohol? All right, so for this problem here, you're going to start off with the amount here, so 0.500 liters, put that over 1, and converting this, you have liters on top, so you're going to want liters on bottom. Now notice you're given grams per milliliter. So what you could do is you could use factor labeling, i.e. dimensional analysis, or you could simply say, let me multiply 0.813 times 1,000. And that's what I'm going to do here. 813 grams per 1 liter. That way those will cancel out for you there. All right, and then multiplying this all out here, you are going to get 406.5 grams of the methanol. Now, before I say final answer, I want to talk to you a little bit about rounding. If I haven't already done so, with regard to the 5 here, because we have 3 sig figs, we're going to need to drop a digit. Now, the question is, do we round up? Do we round down? A lot of teachers have their students always round up, but what that does on average is it rounds up your entire average because you're rounding up more than you're rounding down. So what we're typically going to do with the 5 here is we're going to keep the last digit that we're going to keep, which is a 6, we're going to keep it even. So in this case here, we are not going to round up. We are going to say that our final answer is 406 grams of methanol. And that's going to be our final answer on this one here, okay? All right, so molar volume is essentially the molar mass divided by the density. So if we were to take a look at that, as far as our units are concerned, we have molar mass, grams per mole, and we're going to divide that by the density, grams per liter. All right, so rearranging this, I'm going to go ahead and do that. I'm going to multiply by the reciprocal here, get rid of these guys, and recombine, and look what I have here. I have the units for molar volume. So again, molar mass divided by density equals the molar volume. Okay, so in this example 2, you're being given the density of sulfur hexafluoride. Now, the molar mass of sulfur hexafluoride is 146.06 grams per mole. Okay, so we're gonna, just for this calculation, 146.1, that'll work. So 146.1 grams per 1 mole times, and then we have our density here, and the density is basically saying in 1 liter there are 6.00 grams. So that's going to get our grams to cancel out. It's going to leave us with liters per mole, and we're being asked what is the molar volume. So we have our correct units here. You will get 24.3433 liters per mole. And our final answer, if we round that, we're going to say we need 3 sig figs as dictated by this value here. So 24.3 liters per mole is our final answer for example number 2. Okay, and you should know, and if you don't, this will be a reminder for you if you haven't already learned this, that 1 cubic centimeter is equal to 1 milliliter. So that's a conversion factor we'll use periodically in this course. For our last example here, we're going to start off with let me make sure. Okay, we're going to go ahead and start with, you're given that gold has a density of 19.42 grams per cubic centimeter, in other words, grams per milliliter, and you're told the standard weight of 12.4 kilograms. So again, I can simply say, all right, let me just go ahead and multiply this by 1,000 to get this unit in grams. So 12,400 grams of gold times, and then grams, we're going to want grams on bottom, 19.42 grams in essentially 1 milliliter. So grams will cancel, and you're asked what is the volume. And so the volume is going to get 638.51. However, we need to have 3 sig figs here. And so in order to go ahead and get our 3 sig figs, 1, 2, 3 sig figs in this number here, what I'm going to do is, there's that 5 again, and it's an even 8. So my answer, my final answer is going to be 638 milliliters, or 638 cubic centimeters if you wanted to put that. Either one of those would be acceptable here. All right, so there's no problem set that corresponds with this, but it is a part of your Georgia Standards of Excellence, and we will use these concepts of both density and molar volume throughout the course. Thank you very much, and I'll see you in class.